Back in 1983, Sony released a series of receivers designed for AV use. This was the first of the AV type receivers. And by AV receivers, I mean they could switch between two video sources. So you could have, say, a VHS machine and a Betamax, and have them both on the same TV, which only had a single input. This one here I've got was sent in. It's completely dead. It's quite a unique design. It was the first, I think probably one of the few that actually used this type of power supply. Let's check this one out. This time I have a Sony STRVX750. This one apparently is dead, and it's been worked on before. So I don't know what has been done to it. Apparently it doesn't turn on. I hear a click, but no power. So these units use the infamous pulse power supply that Sony brought out in the early 80s, and when they work great, but when they don't work, they can be a real nightmare. And as far as getting parts go for them, well, I don't even know whether we can get any parts for them to repair them. I know when these first came out, Sony didn't even want anybody fixing the pulse power supplies. They supplied them as a unit, but as time went on, of course, parts kits came out to fix them. But I have no service data on it. I have the manual for it, but the components inside here, it just shows a black box. It doesn't show what the schematics are. And I believe the original service manual did show what was in here. It's just that the photocopy that was used to make the scan, it just shows black. You can't see any of the circuitry. Main filter caps were replaced on here. You can see that. Someone changed those. Let's see what else is wrong with this. I know the filter caps were changed because the fellow that sent it to me told me that when he got it they were leaking. So he changed out the main filter caps. One component that fails all the time on these, and it was one that was eliminated by most servicers just because it was a source of trouble. In fact, the last one of these I saw, it was gone. Do you know what part I'm talking about? It's right there in the circuit. It's a fuse. But you guys don't know which one I'm talking about because you can't really see it, but it's right there. So they've got a thermal cutout, 145 degrees Celsius thermal cutout that sits on top of this resistor, and if the resistor gets too hot, it blows this open. And it's not blown. I was expecting that to be open. How about the other fuses? They're probably fine. Yeah, that one's fine. I was totally expecting this thermal cutout to be opened because it's a real common failure. What happens is if something's drawing too much current, this resistor heats up, and when it gets to 145 degrees, well, the resistor heats up anyway, but once it gets hot enough, this has got thermal paste on it to conduct the heat right into this thermal cutout, and once it gets up to close to that temperature, these things would let go just for the sake of letting go. I mean, there was no rhyme or reason, they would just fail. So it's not failed on this one. So let's just start by measuring at some voltages, see whether we've got power. They weren't my favorite design, these ones, that's for sure. Why is there no top on this relay? This relay's got no top on it. Let's check for some voltages coming off the switch mode. If I'm not mistaken, this is the power out from it. Where is it here? Nothing. 0 volts. Oh. I think I just discovered where the top for the relay is. It's just sitting right there. Just chilling. Just chilling. Do you think they tossed us around in the mail? Alright, so we dig up some paperwork on this thing as best we can. It's probably something failed in here. Again, I do have the schematic for it, I just don't have it printed. But we can print that up and then check for some voltages in various places. See if I've got power going into the DC to DC converter. And I got nothing coming back from it, but is there power going into it? Okay, the input is the orange and the black down here. This is where power goes in, right on this thermal cutout, and then it comes back on the other side. So let's just power it up and see whether we've got any power going to the DC to DC converter. Okay, it should be on right now. Get the damn camera out of the way so I don't bang my head on it. Okay, here's our... Oh, I think the meter went to sleep. No. Did my meter go off? It goes to sleep if you don't use it. Of course, when I touch the screen, I touched it on capacitance. So of course there's going to be no voltage measured. No, no power. No power getting to the DC to DC converter. So if the power is not getting to the pulse power supply, as they call it, it's not going to work. Let's just pull the bottom off this and see what is happening. I like these ones. You don't have to remove the screws all the way. They were easy to take apart because you just gave them a twist. And there was a nice cutout on the base. Just spun the screws a bit. And look at that. The bottom comes off. Okay, let's check the power now. We should have about 150 or 160 volts. Now I got 165 volts here now. I had nothing before because my meter had switched. I'd switched it to capacitance when I turned it on by tapping the screen. That's a downside to touchscreens. But I like the meter. So there is power there, but there's nothing coming up on at the back here. Like these filters here should have power on them, and they don't. So this switching power supply is not working. We've got power going into the DC to DC converter, and we've got nothing coming back on the other side over here. Now the problem with these units is that these were made before they put discharge resistors in. So even though this thing's been unplugged for several minutes, there'll be a big bang when I short this cap out. You don't want to stick your fingers into these goddamn things. Trust me, you don't want to stick your fingers into these ones. They are quite dangerous to work on. That capacitor had 165 volts in it, and it's a, well, how big a cap is this thing? It's 1,000 microfarads and 200 volts. So these ones here are quite dangerous to work on. These power supplies, lots of people got jolted pretty good from these ones. I'll open up the switch power supply, or switch mode power supply as these are called, or pulse power supply as Sony called them. See, there were, if I'm not mistaken, it's been a long time since I've seen one of these things. I saw one not that long ago, but I mean as far as the PPS, the pulse power supply, I haven't seen one of these in probably 40 years. They were generally pretty reliable, but when they blew up, they blew up pretty good. And if I'm not mistaken, there's parts in here that you can't get. These things were just completely shielded tight. As you can see, there's an end plate there. There's another end plate here, and there's a cover, and there's a whole bunch of shielding. When these started to break down in the field after the warranty was up, I would say 9 out of 10 people just abandoned them. They bought a new one. Now you might be wondering why all this shielding. Well, that's because when these came out, there was such concern that they were going to cause interference to radio and TV that the FCC made Sony completely shield this in its own Faraday cage. And that created problems on its own, heat being one of them. Yes, you can drain the heat away through the cabinet itself, but the fact that it has no fins on it, once this whole block got hot, things tended to cook inside. They weren't the most reliable unit that they ever made. In fact, I think probably on the reliability scale, these were probably one of the lower ones because power supplies were getting cooked. We used to change the power block a lot of times just as a power block because of the amount of damage that happened when they blew up. You know, we're talking caps exploding, transistors shorting. So here we go. Got a couple caps in here, and there's a resistor array down there. There's some crap that's glued in with circuit glue. One thing I don't suspect right now is a catastrophic failure. And the reason I don't is because that would blow that fuse if there was something that shorted in here. I'm opening it up because I'm hoping it's going to be a connection or something that's gone bad. And that's what's preventing it from running. But you gotta remove all this stuff to get at it. You gotta remove the heat sinks and everything, because I got to slide the board out of here, out of this base, right? So I mean, just the amount of work just to get at it, just to get to the bottom of the board, because this board itself is fastened down. There's a couple more screws in here. I got these end pieces that are now undone. I have to undo some more screws inside here. And if you look at these capacitors, they're only rated 85 degrees in a switch mode power supply. Yeah, way to go, Sony. But again, when these were made, this was brand new technology. This was cutting edge technology, these switch mode power supplies. I think this was the first stereo receiver that used it. I think probably the only stereo receiver actually that used it. Okay, to get this board out, I have to remove these heat sinks. I got to pry the transistors off the base plate here. I also have to remove the heat sink back plates that hold the transistors and diodes up against the back plate. I have to remove both of these. This one's an insulated one. It's got a metal plate on the back side of it here. And now I can remove the board. Well, I should be able to remove the board. There we go. Okay. Now we get to peek into the bottom of this thing to see where our fault might be. I'm just inspecting the board closely right now, looking for any cracked connections, and we're in the drivers down here. This is a resistor array here, this IB1. It's just a resistor array. These are the driver transistors, Q901 and Q902, and they drive these output transistors, which are not shorted, because if they were shorted we would expect to see carnage up ahead. I'm just going to grab my old fluke meter now, only because I've got crap on my hands that I don't want to touch the touch screen on the other one and contaminate it. But here's our transistors, right? They're not shorted. I have to disconnect one lead. It'll measure shorter, like between the base and collect our base and emitter, just because there's coils here, right, to connect the two of them. There's a transformer. These ones use a bootstrap capacitor, and that is one of these little ones down here. I think it's this one, C904. That little cap, when power is first applied, this is your B plus comes in here, right? Goes through this coil, charges this capacitor here for starters, continues along over and charges up this capacitor as well, but it also charges up this capacitor. And when that charges, when that capacitor gets hit, you get a pulse that comes through here, goes through R901 into this resistor array, which will then bias on one of the transistors, which will turn on one of the outputs. And when it turns on, it creates a pulse which biases it off and turns the other one on. So you get these two transistors going back and forth, one on when the other's off, which creates an alternating field into the transformer primary here. Right, you get an alternating field across the primary, and that also creates a pulse in the secondary here, or this one secondary winding, which is what is used to turn the other transistor off. It's just a self-oscillating. So it's quite a simple system. It's not really regulated like you would think of as most pulse power supplies, where this one was not. It did have a lot of this crap glue though, this circuit glue that's on here that goes conductive. So we're going to clear that out of there first. Got to get rid of that for starters, just because that's a source of problems. You've got a little bit of leakage on there. Shut everything down, and there you can see there's quite a bit of it in here. It's all turned to a dark brown, which is what it gets to when it becomes conductive. It changes to this brown color, and causes all kinds of headaches. So we're going to remove this stuff first, in around here as well. Get that all cleared out. If you look down here, you can see it's gone green. I think that's probably been eating into this wire here and causing a short. You can see the green. Oh, that wire's broken. Well, that might explain why it doesn't work. That one's eaten right away off of this coil. So that might be right there why this doesn't work. You see that coil that's broken? That wire right there is snapped right off. It was all green probably from the circuit glue. This stuff is just brutal. Anytime this stuff is present, you gotta wonder what's causing the problem. It's quite often it's this crap that they put on here to deaden vibrations and stuff, and well, it deadened stuff all right, that's for sure. I want to get this one here cleared out as well. There's more in here on top of this one. I have to be really quite careful while I'm doing this, because there's wires in here. It's not just this circuit glue that's poured in here on top of this coil. There's actually wires there, and I got to get this out of the way. I got to cut this out so that I can open it up and get that piece of tubing off of the transformer, so I can clear all that deteriorated glue off the transformer, off the wires. Of course, I'm fighting the circuit glue on the top side that's holding the choke coil in place. So it's making it hard to get this thing unsoldered. There we go. Now I got out the choke coil that's damaged. Now I just have to repair it. You can see where the wire is eaten away here, where the glue is right on it. This wire here is just burned right away. So let's see if I can maybe pull one loop off of it, or at least lengthen it enough that I can reconnect it. I mean, this is just a choke coil. It's not even really needed. It's just on DC. But this is likely where my fault is the this one here was burned right off on the board. You can see right there where it was burned off from contact with the glue. Okay, I shortened the coil up a bit. I just took one winding off of it, one turn off of the winding on each side, so I could get enough slack to pull the wires back through the board. And we'll tack them back down, and then I'll just try this thing. I'll try it on the dim bulb tester with the cover off, of course, and see whether I get any power. I'm only going to turn it on for a second or two because I don't want those transistors to overheat, and they will if there's no heat sink on them, and they'll overheat pretty quick. So I'm just going to set this outside of the unit so it's not touching anything, and we'll try powering it up and see whether it turns on. If the display lights up, then I know it's working. Then I can discharge everything and put everything back together. So let me just clip off this excess wire here. Okay, we're going to move this away from where it can touch anything. Maybe outside like that. I'll turn off the main power. And I'm going to plug this into the dim bulb tester and just flick it on momentarily and see whether the display lights up. And that'll give me an idea whether this is going to actually work or not. I don't know. I cleaned off that glue, right? So I don't know whether there's any other problems with it, but definitely where that glue was, that certainly is there was certainly a green around the negative terminal, and it was broken open, so that will certainly cause a problem. I still see nothing. So it's more than that. But it may not start on the dim bulb because the voltage is low, so let's just try starting it. Oh, okay. Ah, I got a display. It works. Here, I don't know if you saw it or not. We'll do it again. Observe. It works. Excellent. Okay, let this sucker discharge, and we'll put it back together. And this one should be fixed. And I know that's going to make the guy that owns this real happy, because it came a long way to get here. This receiver, it came from the home of the Penguins, the Pirates, and the Phillies. I think you know where that is. Pennsylvania. Long way to come to be repaired, but again, there's not a lot of people that know how this stuff works, are familiar with this equipment anymore. And apparently I'm one of the few that still understands how this stuff works. And because most of them are retired, long retired or dead. I think a lot of them probably are retired and dead for this stuff. So there's not a lot of people that are familiar with, especially with that power supply, because this one here, again, was quite unique to this particular unit. It's kind of overkill. And to tell you the truth, the caps that are in here, I've never seen them go bad, even though they're not high frequency rated caps. I've never seen any of them go bad in here, because this unit does not operate at particularly high frequencies. Unlike the more modern switching power supplies, this isn't operating at no 100 kilohertz or even 50 kilohertz or 40 kilohertz. These are quite low in terms of frequency. I don't know exactly where it is, but they're quite low. It's out of the audio range. You know, maybe 30 kilohertz, maybe. It's out of the audio range, but they didn't use real high frequency caps and real high temperature rating caps. Still got 12 volts on here. It's discharging slowly. We'll help it. We'll help it along. We'll just do that and just get it discharged so that I can start to reassemble the unit. And then we'll see if everything else works, which it should. But again, here we go. Circuit glue. That crap circuit glue that they had on here, which I've removed. I'll get now that I've discharged this thing, we can take a look at the board itself, and you'll see that it was all it was all around in here. I'll put some silicone in here before I put it back together, just so things don't, things don't buzz and vibrate and stuff. But they had it on this here, and they had some here, and they had it under here, and they had it around on this transformer here, and they had it on this one. And this stuff is just crap. It's just terrible stuff. And it just, after all those years, it just corrodes and, it just fails. So, but you can see none of these caps are leaking or bulging or anything. They're the Nikon caps. They were good caps that they put in here, but they are not being worked real hard because this transformer here is not operating at a particularly high frequency. It's relatively low by pulse power supply or switch mode power supply standards. This is quite low. But I'm going to throw some silicone on here now just to keep things from moving. And then we'll start reassembling and getting the unit back together. I got to do this just because, just in transport, a big unit like this bumping around, it could break stuff, right? So we want to make sure that it doesn't fail again. So put some silicone in on top of these coils and stuff that were glued with that Sony bond crap before. Do it right. Okay, as I reassemble the power supply, this is the fun part, getting these metal plates to line up. Kind of hold them in place with a pair of pliers as I spin the screw from the other side and try to catch it over here. Maybe we'll do it by hand here. Get the screw to thread in. There we go. And then that'll tighten down and pull those two diodes up against the heatsink. You gotta do the same on the output transistor side here. Gotta slide this down in behind here to pull the transistors back up against the main heatsink. Get that transformer out of the way. Okay. Of course, the part of the problem with putting silicone on there is that it's messy until it dries, and I don't feel like waiting a few hours as I put this thing back together. Okay, good. That will hold that in place. There we go, that's good and tight. Now I can start to reassemble the power supply. I got to make sure that these little cable cut strain reliefs are in place. And then I can throw the top cover on. Notice that there's a gasket. I don't know if you can see it or not, but there's actually a gasket, an RF-proof gasket in there to stop leakage. Isn't that ridiculous? The amount of shielding that they put on these bloody power supplies because somebody was afraid that they were going to cause interference to radio. They probably would cause interference to radio. That's why they did it. But it's ridiculous, the amount of screws and the amount of shielding that these early switch mode supplies had. And of course, and even the old TVs, right? The old LCD and plasma TVs had so much shielding on them. That was half the weight of the set, was all the bloody shielding, the metal shielding around everything. And of course, TVs today, well, they're just plastic. They got no shielding on them now. Are you kidding? You can lift a 65-inch TV. You can lift with one hand. It's crazy. The how light everything has become just because, and a lot of this was just excess shielding that was put on, like these for RF radiation control. Not that these are going to radiate much RF, but back then they took nothing. Nothing was taken for granted. Everything had to be completely shielded, and you could not cause interference to radio. Now I don't think anybody cares, right? With all the crap that's out there now spewing out RF, I don't think they care about that anymore. AM radio, who cares if the AM radio gets interfered with? But 40 years ago, that was a big deal. Anyway, I'm going to stop the video at this point as I put some more screws in, because I'll be putting this thing together for the next 10 minutes with all the shielding on this thing. Believe it or not, this ground screw is probably one of the most important ones in the unit. If you don't put this one in, you have no sound. Why? Because those are the speaker grounds. The speakers are grounded to here, and then this is grounded to the main board. Brilliant design, Sony. Brilliant design. You see, they had cutaways for the screws that hold the unit together. So there's 4 screws that hold the unit to the cabinet, and then 4 more that hold the cabinet together, the power supply together. So now the power supply is mounted back into the cabinet. I'm going to redress these wires a bit, and then we'll plug it in. All right, let's see what happens. That's a good sign. Where's my volume? Speaker's on. Why is there no sound? Oh, there it is. Oh, that's just that transmitter's low on the right side, I believe. Gotta tick into that. Let's try, how do I do this here? I forget how to do this to enter channels directly. Direct access. How do we do this? Jeez, Christ, I forget. There you go. It's working! Excellent! Probably can't get this. No antenna and it's still picking it up. Okay, so we'll put one in the win category for this. Repair the pulse power supply. And again, not really a lot goes wrong with these units. I can't remember the last time I had to repair one. This is the first for the input choke being dissolved by that circuit glue, but again, now you see how bad that circuit glue is. It turns black and it starts to go conductive. And just because it was sitting on the wire and it was also touching one of the leads of a capacitor as well, you got a little bit of current flow and electrolysis set up, and it just ate away the copper on the negative terminal. There's always a negative terminal that goes, right? Always a negative terminal, because the copper migrates from negative towards the positive. It's electrolysis. And eventually it just gets thinner and thinner and thinner, and then it breaks. And that's exactly what happened. Electrolysis set up from that circuit glue that became conductive after 45 years. It's probably been conductive for a while, but it took that long before it acted up. But most of them acted up long before that. I was having circuit glue problems in the 90s with components failing due to circuit glue. Never seen it on one of these before, but there's always a first, and that was the case here. It was a first for this one. Now I got to put the bottom back on it. Everything down here looks okay. I'll just give it a quick inspection before I before I throw everything back together, but everything's looking good from what I can see here. Yeah, no antenna, that's why the signal's fading out. Anyway, the bottom goes on just as easy as it came off on this one. The only downside to these ones is that they tend to scratch everything because the screws, when you take the screws out, there's no feet, so you drag it across the bench and you end up gouging the bench. That's something to keep in mind. If you're working on one of these things and you've got something that you're on a workbench that you don't want to scratch up, better take the screws out completely. All the clips are in, and then you can just put this thing back together real quick. Just a couple turns per screw. Alright, this one's all done. I don't need to test it any further than that because it was dead when it came in, and now it's working. Yeah, I know. Now of course it needs an antenna because the top cover is going on and it's shielding it from the signal. Even though the transmitter is just across the shop, it's only like 2 or 3 milliwatts of power. It's just one of those MP3 player FM devices that you put in your car. That's what's playing music for my test station. The one I use for rebroadcasting FM 98 for my in the house is a Ramsey FM1 transmitter. But it's only putting out like 50 milliwatts. If I'm not even thinking like it's 10 milliwatts. It's not running an amplifier or anything. It's just what comes out of the unit. Because I don't need Industry Canada showing up at my door. So, but it's amazing how far the thing goes with just what's coming out of the unit, which again is, I don't know, maybe 25 milliwatts, if that. I don't think it's any more than that. It's very, very low power. Just what's coming out of the unit into a proper antenna goes about a block. So that's far enough for me. All I care about is that it makes it around the property so that I can test radios and stuff. Same with my little AM transmitter that I've got as well. It's putting out a little bit more power, but it still doesn't make it past the end of the block, and that's intentional. I don't want it to go much more than the property just for obvious reasons. I don't need to get a knock on my door, if you know what I mean. Anyway, thanks for watching. We'll catch you in the next one. Bye.